Good morning and welcome. I'm Bill Wake. We're here working on an interpreter for basic, kind of 1980s era basic. And we've started yesterday with the REM statement, which is the remark or comment statement. And so far, we talked about interpreters yesterday. What we've done so far would come under that lexical analysis category. So we developed something that you give it a string and it can find the line number and the remark statement to the end of the line and then the next line number and so on. And if I were doing this 30 years ago, I probably would say, okay, let's go in there and do all the lexical analysis. There's 85 kinds of tokens. Let's get them all implemented. Now I'm more inclined to take a slice through the system. And so even though we only have one statement that we're analyzing, I want to move on to the parsing and start to get a grammar going and start to get the notion of what kind of trees we're going to build. And then once we get the parsing going, do interpretation. So we're going to have the worst program in the world. It's like 10 REM, here's a program that does nothing. And you run it and nothing happens. Or it just stops, okay? That's actually progress. We have, let's see if I can find the documentation here. One more. All right. This is sort of a summary page of this basic. It's got, 4, 8, 12, 16, 22, something like that, statements and a bunch of other things that it does. You don't need all 22 statements to do stuff. Okay. So, yeah, REM's a little boring, but it's like the easiest one to do, I think. I guess and or stop would be pretty easy, but REM is up there anyway. And so putting REM in place, we've got that slice going, and usually I draw things so it's vertical. In this case, it's a horizontal slice. We're getting through each stage of the system, and then we can see the consequences. So if I made my stream of tokens and did every possible token, and then I got to do my parsing and go, oh, I don't like the way I did these tokens. I don't find out until the whole phase is done and I have to rework everything. By doing these little slices across the whole system, the hope is that we find the major issues and kind of resolve them when things are small and not when we've already invested so much. All right, let's see what else we said here. All right, so yesterday we did basic line format, the line number and a statement. We did the tokens for remarks. We haven't done parse and interpret. And when we finish remark, we'll go on to print and so on. Okay, so just kind of keeping track a little bit here. All right. The other thing, we had some things in our to-do, so let's look there. So run a REM program. Well, I definitely want to do that. We also had this notion, what should lecture be? Okay, so already it's like, oh, is this thing quite what we want? All right, and I think, well, stream is such an overloaded word. I think what we want to look at is sequence. Okay, that's the protocol that collections use and other things use that provide values in a row or a stream of values, and then you can say forward token in something and things like that. Okay. So yeah, so I guess that's two sides. One is the input side. Should we work with array of characters? The other is the output side. Should it be a stream? I'm going to change that as if I were all knowing and it was sequence. Let's deal with that one first. Or would it be better to do the characters? Well, I think the sequence is going to be easy-ish. If it's going to work quickly. Okay. So let's see. I found a page somewhere. Okay. The sequence protocol. You basically have two options. One is you can provide a make iterator method that tells how to iterate over this thing. So just how to get the next value out. The second alternative is you can say you're a sequence and an iterator protocol, and then you just provide a next method. Now this is mutating here because it's a struct. I don't know if it has to be mutating in the other one, but it looks like what we can do is just say this much on our sequence, on our class. And let's see if that just is going to work. All right, so here's Lexer. Lexer's type. Okay, let's try giving him this. Now he should complain, I'm guessing, that like, hey, you don't have a mutating method. Okay. Does not conform. Do you want to add protocol stubs? Yes. Alias element equals type. I think this is token. Okay. Do you want to add protocol stubs? Oh, this is iterated protocol. Okay. Now I have a next. Yes, fix. Let's try and compile and see what it does. Just has no matching type, goes to nothing, goes to token. Do you want to add protocol stubs? Well, oh, there it goes. Okay. Let's compare down here. Function next, so they want a token question mark. Command module failed to emit. Okay. I don't think we'll ever. This is the at end handling. Okay. We will always just keep returning at end if they ask for it. So ours is kind of an infinite sequence. It's all your tokens that you have, and then it's just at end every time. Okay, so I think that's legal. I mean, there are infinite sequences out there. All right, so let's try our test again. And what I'm hoping is that this will just make, we're just kind of conforming to existing protocols, and then little helper stuff will just be available to us. And that went pretty good. So, all right, let's, we made Lexer conform to sequence and iterator protocol. I watched Paul Hudson had a workshop over the weekend, and I noticed he does the same thing, try and articulate the word to try and spell it correctly. Yeah, little tricks, I guess. Okay, now, should Lexer be a sequence? Let's see. So let's mark this as today, 2202. It's May 10th. Whew. And this, and the answer is yes. And an iterator protocol 2. All right. All right. So I think that will help a little bit somewhere. Another reason I was wanting to do this, as I was thinking last night about the parser, we can set up, our test could set up the chain, so that we have to fully parse lexical analyze them, and then feed that to the parser. But if we were just a sequence going into the parser, we would be allowed to ask just next like we're doing, but I could give it an array of tokens for test purposes and stuff like that. So I think that's going to be a good thing. All right. Should Lexer work with array of character? Oh boy. Yeah, this is this challenge What's the deal? The challenge is that strings in Swift kind of reflect the full complexity of Unicode. And that complexity is like some characters are multi bytes, an arbitrary number of bytes. So you can have a character, because you can add umlauts and stuff like that as a separate character, or a separate, yeah, I guess a separate character. I'm not sure the terminology, but you have like E with an accent, okay, and you could add an acute accent and a grave accent and an umlaut and whatever else you want. You can just keep appending these on to an arbitrary length, and you know you can't represent them as simple characters of fixed size of any sort. Okay, what we've done, we we've treated it as a string. And if you remember, we squeezed out the spaces and we appended a new line just to kind of normalize things. But then we have this index. If it were an array of characters, how would that go? I mean, like sometimes we definitely want characters. I don't know. Yeah. Hmm. Where does it get complicated? Well, one place we see it is this stuff. We can't just say start index is a character position. We have to um, we have to do this program.start index and all that stuff to try and take into account that the start index of a given character might be arbitrary many bytes from the previous character. But I think we're not going to get away from it, right? Because if I had this thing, I guess the result would be if I switch to an array of characters, when I get down here, I'm going to have a starting index and an ending index on an array of characters, and I still got to convert that back to a string because we want the name of a thing to be the string and so on. Um, hmm. I'm gonna leave it for now. I just may regret it. This stuff is just more complicated than I want to look at, and I don't know if I can. Well, maybe I can pull this out. Program index offset by index. I mean, we need the program, and we got an index. Okay, let's try that. A little helper. Function. I don't know what to call it. So for now, it's going to take a program of type string and an index of int. It's going to yield us whatever this is, string.index. Yield string.index, okay. And it's this. If it's the only thing only expression in a function, you can it just returns that by default. So that should be okay. Let's rename this to a string. Okay, And then what's this doing? It's getting the... I'm going to call it index. I don't know if I'm allowed to. Index. And let's just call this, let's rename this to at. And then make that required. And I think that'll be somewhat readable. Okay, so now this is starting index equals index of program at index. Oops. Okay. Now I could hard code program in there. Because that's the only string we ever talk about. Okay, let's see, let's make sure it runs. You know, I've forgotten what the keystroke is for tests. Is it like Control-Shift-U? No. Okay. Just Command-U. And we expect to pass. Oh, it's running all tests. Ugh. Oh, let's cancel that. Let's just run these tests. Okay. All right. So that's an improvement. Index program. Index of program. At index. Okay. This would look better if I really gave it a full width. Okay, let's see. How's that looking? All right. So get the index for program at. I don't know. Maybe that is just the string. And let's see how I feel about that. Okay, so index program at. This goes away. And we're doing program. I don't know, usually I'm pretty explicit and don't let stuff be side effects on, even side effects at the class level I often kind of avoid, but I do want this to be more readable. Okay, index equals index at index. It's an improvement, I think, but I bet I could do better. All right, let's try another thing. Let's focus on this one instead. Let's make a method substring. And we're going to give it a start and an end. And it produces value. What is the type of value? Substring. Well, I'm going to produce the string. Okay, let's get that going. Okay, so what it's going to do Well, it's going to do this stuff for sure. Okay, start. Okay, and now let's do this. Ending index. Okay. Now, nobody's calling it yet, so this is me arranging things. All right, so I want to start at start and end at ending. And then I'm going to fetch all that and get it out of here. Okay, so I think if I let's keep track of that index for a moment. My start equals index. Okay, now we get down here. Ending index is really index. Let's return. Substring my start and index itself, because that's really the same as ending index. Comment out these two. Make sure it works. Yeah, I don't mind that for the moment. Should pass. Yeah. Okay, so now I don't need this mess. All right, I think that's a better way to go. Now that little helper might be helpful still, this index thing. I think I can inline these and be just as communicative. If I had inline, index at start, to index at ending. To program this range, I think let's call this start index. Mutable value start index was never used. That's start. No, he's still confused. Okay, let's try this again. Okay. I'm happier. These are kind of ugly, but this is definitely better, and it makes sense to me now in a better way. So we grab the starting position, we increment while things are valid, and then at the end we return the substring from the start to the current character. Yeah, I don't want to mess with all the string index stuff. I just want to keep a simple counter and use it. All right. And yeah, I have to underneath, but that's okay. All right. So what I'm trying to do is kind of get these pieces, like kind of these. Okay. These are like helper methods for me doing the processing, and then down here is the real token specific logic. Okay. And it's kind of too bad there's not built-in stuff like this. Maybe there is somewhere, but it would be nice. Okay, but now, all right. So now our lexer is a sequence of tokens. Okay, and it at least sometimes works with the indexes we like. So I'm calling that a win. All right. So clean up how we manage string indexes. So we can just use int most of the time. All right. So that little detour to clean up stuff, should Lexter work with character? We're going to say no. At least tentatively, no. But we did clean up indexing. Okay. Now, let's run a REM only program. Okay. I'm going to break this up again. It's because I have a design I know I've used, I don't know, a dozen times. Breaking things into a lexer, a parser, and interpreter or code generation. Yeah, it's just a proven design in the compiler and language implementation world. Okay, so what I'm going to do is I'm going to say now, assuming I can produce my stream of tokens, my sequence of tokens, fine. Then let's deal with the parser. Okay, so I'm going to make a parser test. A new file. Swift XC test suite. Yeah, let's say unit test case. And this is Parser Tests. Okay, it goes in there, yes. Okay. Now, all right. And then, well, if we go back to our picture, what our parser is going to do is, given some tokens, produce a tree of nodes. Okay. Now we don't have that tree. I guess I can call it parse tree. What would you call it in English? I don't know what you call that. A parse, sentence analysis, whatever. Maybe it's a parse. Okay. But we're gonna need another class. Okay. So let's work a test up. And as usual, I'm gonna kind of kill this stuff off because I'm not really using it. And the body is no use to me either. Okay. So what we're doing is, if you're going to parse, you basically need a grammar. And so our grammar, there's a program and it consists of lines. All right. And a line consists of a line number, and a statement. Now, in the long run, we're going to allow colon, statement, star, or something like that. The idea is that you could have more than one statement on a line. That was allowed in these old basics. Okay, and the way they did it with the colon separator, there's some complexity because the if statement kind of overrides. It wants them on the inner side or something. But for now, we're doing this. So the grammar, I don't know, you may not have run into this, but this is sort of a notion, we call it metasyntactic. It's about the syntax of the language. So you have rules where the left-hand side is what we call a non-terminal. It's going to have a further explanation. Okay. And the right-hand side is a sequence of either terminals or non-terminals. And in our case, well, let's get line number. Line number is an integer, and I'll kind of capitalize these or something to kind of distinguish them. But in our token analysis, let's see if I can find a tokens. Here's token. Okay, we have a line which has integer. It's the same as this, so I'll call it line. Ugh, no. Yeah, I'll just say integer. Okay. The fact is it's really this line token. Maybe I can do it that way. Oops. Okay. I could say int and probably communicate just as well. All right. So line number statement, this line start lines, I'm going to use some other notation that says you can say one or more. Okay, I guess, or zero or more. If you want star is zero or more, plus is one or more, kind of like regular expressions. All right, so my program consists of a bunch of lines. It's a line number statement, and then we sometimes put things in quotes to say this is also literal, new line. Okay, and if you didn't provide the last one, it's provided for you. And statement, well, what we have is statement goes to REM, and then I guess I'll quote that because it's REM token. Okay, and it's arbitrary text. We'll say dot star, and okay, so I'm stealing some regular expression notation. Dot is any character but new line, and star is zero or more. So I'm mixing up my notations a little bit, being sloppy, and there's some sloppiness around here about matching up to our tokens and stuff. But mostly I want to convey to myself so I, don't make any mistakes in how I'm parsing. Okay, and let's see. So remark to the end of the line. That's the only statement we support. I could also, as I add others, I can repeat these. So statement goes to if, etc. All those others. I guess print is the one we'll do next. So we'll hint that's coming. All right. The nice thing with this grammar, you can analyze it and make sure. Well, there are constraints you have on grammars, and if you follow those constraints, you can write pretty straightforward parsers. In our case, we're going to use a technique called Recursive Descent, which says make every type on the left-hand side, make it a routine. So there's going to be a routine program, a routine line number, statement, and so on. And to parse something, you just look for instances of the stuff on the right-hand side. And if it happens to be another a non-terminal, then you call that method. If it's terminal, you just require to match it. Okay. So the point of parsing is we want to get this tree out, and the tree, I'm not quite sure how I want to do these at the top level, but I'm sort of imagining a program tree node that consists of an array of an array of nodes, and those nodes are going to correspond to statements, which is going to be, well, they're going to correspond to lines, which is a line number and a statement. Okay. I don't know if I'm mucking things up for myself, but what I'm imagining is three types at this point. One for the overall program, one for a specific line, and one for a statement. Okay. And let's see how that goes. Okay. So some tests. Let's close this one. Close this one for now. Parser tests. Okay. So we're going to let program equal 10 rem. Whatever. All right. And we want to parse that. Okay, so we'll let parser equal parser. And we're going to have to give it something. Okay, and this is where I was thinking my stream might be the right thing to do. My stream of tokens. So I could give it the token 10 and the token rem, a line token and a rem token. That's the stream that the lexical analysis or lexer is going to produce. Okay. At any rate, if I had this thing and I had a parser and I said, let result equal parser.parse. Okay. Then I want to assert result is, well, this is where it gets tricky. Okay. I want to say that that should be a tree. Well, or a parse. Okay, this is where we're making the decision, so it's kind of the key point, I guess. And let's see if this holds up. Okay, so I'm going to make a parse. I'm going to say parse.program takes a line. Okay, and the line is parse.line with a line of 10 and a statement which is a no-op. I don't know. I don't care. It's a remark. It's really just a no-op to me. No-op is nothing. And some people write it this way, and some people write it this way. I guess we could be more explicit, maybe. Parse dot do nothing. Parse dot skip. Can I say skip? Okay. So what you notice is I'm sort of pretending it's an enum, but it's a tree. Okay, and there's a technique for that. I think it's called indirect. And let's see. So we define the parser. All right, let's define the parse. New file. Is parse. He's part of BASI. Okay. And this, I think we say indirect enum. I looked this up too. So indirect enum parse. Okay. And we have case program, which takes an array of parse. So you can see this is the recursion. And we have a line, which takes a token.line. Can I say it that way? I guess I'm going to just say token. And it's going to take a statement, which is a parse. And we have skip, which takes nothing. Okay, I think that's the way you do it. Where did I put that documentation? Protocols, data types. No. Yeah. It seems kind of okay. Cannot find parse in scope. Oh, well, you don't have your testable. I don't know why it doesn't include that. I feel like I'm missing John's helper package or something. Okay. Can I find a line? Well, let's say token line. Global function of circle requires parse to conform to equatable. Yes. I don't know if I get that one for free here. Okay. Parser does not exist. All right, let's add that. New file. Okay, and its method was parse. Func parse. And that we got to work out. But it's going to produce a parse. Okay, that much we know. Let's just return skip for now. Okay. Does that... I don't know if there's a way I never can tell when I can just say the name of the thing or I have to be specific. Okay, cannot find parser. Okay, well, we just said parser.parse. All right. This is going to fail. I don't think it's... Yeah. I mean, I could pass that in. I got to pass something in. I think what I want to pass in, though, is... I think I want to pass... token.line 10 and REM remark. Okay, so this is what our lexer would produce from this program. And so I'm just going to make this a comment. Maybe I can even do this. 10 remark. That's almost what it's testing. 10 and remark. Okay. Now this thing wants this. I don't want to pass an array. I want to pass a sequence. Okay. So let's initialize. Init. And this should take a sequence of token. Let's call it input is sequence of token. And we're going to ignore it for now. Okay, because we're just trying to get a failing test. Okay. All right, I think we're on track. Let's see how this does. It should fail. Yeah, not quite what I wanted. Cannot find parser in scope. That's weird. Cannot find parse in scope. Why not? Did I not save this? Okay, let's clean. Try again. Totally different. Okay, cannot specialize non-generic type sequence. Really? No such module. What? Am I in the wrong folders here? Parser Test is in the basic tests. Parse is in basic. This is weird. And that's exactly the stuff copied from here. And we ran that one. Again, I'm going to clean out this junk. Let's clean everything. And run our tests. Cannot specify. Okay. I thought I did that this way. Is that not right? Well, I think this is failing because this is failing. Wow, how do I get an access to a sequence? Countdown. Maybe I want toga. Lexer. I don't want to do that. Well, let's build it and see, but do I care? All right. Well, I'll tell you what. This is a good time for a break. And usually try and schedule them around 40 or 45 after. So, with something weird going on, maybe clear my head a little and see if I come back with a brilliant idea or at least an adequate one. All right. But the problem I'm having is, I think what I'm getting with sequence is some helper stuff around the tokens, but it's not quite letting me work the way I thought it would. Now, what I could do is I could create a simple lexer, like a test lexer that takes an array of tokens and spits them back. And that might be the way to go. We will see. All right. Anyway, we'll take like a 3-minute break and come back and give it another go. All right, welcome back. So I guess my choices are I could either create a test lexer that takes a stream of tokens like this, or we can just use the real lexer. And at this point, I'm going to take the lazier way out and do the real lexer. Whatever. All right, so parser takes a lexer. And remember, we're still working our way towards that failing test, so I don't want to take too long on this. This is lexer with program. It's pretty realistic. Okay, parser.parse, and that complaint goes away. Let's try this. Should fail pretty quickly. Okay. Skip is not equal to program with all this stuff. Okay, because we just hard-coded skip to come back. All right. So, oh boy, let's see. The way this works. Okay, so we're back to our grammar. We got this program with lines. Okay. What we want to do is, well, we're going to have methods that correspond to each of these pieces. All right. And then the other thing you do is if you can get that first token as sort of the it's like the next token to look at. Okay. So you go into each method, you've always got the next token you want to look at ready. Okay. So this is a token, and we're going to call token equal lexer dot next. Okay. And whoops, I guess we gotta save our lexer. That one probably is just a lexer. Lexer. Okay. Now this is where I got to decide. Maybe sequence is not helping us. Because we know we always get tokens. All right, let's get through it, then we'll deal with it. All right, so we save our lexer so we can talk to it. We get our next token. We kind of prime the pump, as they say, get this thing ready to go. Now we go into parse. Well, parse is really program, okay? And the result of that, if you recall our parse, is a program of an array of parses. So we're going to want to read the lines, and so we have a repetition. Well, what's the possible possible values? If there is a line, it starts with a line number. If there's not a line, it's an add end. Okay, so if the token is add end, and maybe that would be a better first test, but okay. If it's at end, then we're just going to return the results. Okay, so we need to accumulate the parse values. Okay, so let results equal nothing, and that's all we've found so far. While token is not at end, we're going to do something, and then at the end, we're going to at end. Okay. At the end, we're not going to return a parse.skip. We're going to return a parse.program. Hello. Not a good sign. Okay. We'll let Xcode catch up or fail. At any rate, it's going to be parse.program with results. So all the lines we've accumulated. Oh, I hate to reboot this thing. Yeah, not good. Force quit. Try Xcode again. Wow, it even lost all my... All right, we're looking at parser. Okay. We lost a bit there, didn't we? Okay. So while the token, well, we had results. Let results, var results is an empty array so far. While the token is not at end. I keep forgetting I don't need these parentheses in Swift. While the token is not at end, we're going to do something, and then at the end, we're going to return parse.program with results. And I don't know, let's say lines. Make it even more clear what's going on. Okay, so that tells you array parse. I got that backwards, don't I? Okay. All right. So an empty program would have been a better test. Yes. Okay. But here's where we are. All right. We got an array of lines. Somehow we're going to accumulate them. And at the end, we're going to return parse program with the lines. All right. So let's run this parser test. And it's not going to pass, but it's going to have a little slightly better result. The parse.program is going to match, but the body, the interior, is not going to match. Okay. That's all fine. We're going to mutate it in a moment. I don't know. Seems awfully slow. And this is a pretty new Mac. I mean, I'd been using an older one for a while. But testing 2. I mean, it appears to be making progress, but I hope I haven't put myself in a loop. I have, of course. Okay, let's stop. The token is not at end. Well, we didn't do anything that would change token, so let's do that. This is not the right code, but let's at least move forward through our stuff, hey? Okay, try again. Okay, program of nothing is not equal to program with stuff. All right, that's progress. Now, again, look at our grammar. It says programs should be a bunch of lines. And we know that if you see at end, you're done. And if you see line number, you want to keep going. Okay. We don't have to worry about seeing the line number because we're just going to, we're actually going to flip it. Okay. If whatever the start of line is line number. So if it is a line number token, we have to go down 2 levels to find it, but it's there. We know we should loop. And if it's not, then we know we are done or we have an error. Okay. So here, let's flip this. If the token is, this is where I'm not quite sure how to match that, but token dot line. Yeah, how do we do this? Is there a whilelet in Swift? Yeah. Yeah, whilelet equals something, then do something. Okay. So if, okay, while, it's not quite the right thing for me. See, this one, it does it while it's not nil. This is interesting. And this is the difference of the way sequences want to work. Okay, let's back it up again. Okay, while the token is not at end. Okay, see, the problem is line takes a number and we don't know what that number is. So I can't say it's equal to anything. I can say it's not at end. Okay, so if I did this, the recursive descent way is I'm going to call line. And I'm going to say lines dot append line. Okay. And this is going to belong down in line. Okay, so let's see if this kind of works. All right. So parse or program, maybe I should, I'll work on that too. Cannot find line. Okay, so let's write line, function line, produces a parse. All right, now line has two things in it. It has the line number, a token, and it has a statement. Okay, so the parse for line is we want to capture the line number. Let's see. I really want to say, I want to find the type of a token. So we have check type of enum without looking at associated value. Hopefully that's the magic words. Yeah, that's what I want. Card equals card rank dot jack. Okay, yeah, jack. That's fine. That's fine. Yeah, binary operator cannot be applied to operands, card rank, and int. Yes, okay. No. If case. Oh yeah. Yeah, that'll work. Yes, I agree, it kind of sucks. Yeah, I think if case is what we want. Where we find it, if case dot number equals number. Ignore the value. Okay. If case. Token equals dot line is that better? If case dot line equals token. Okay. Then we know we have the line number. Okay. Let line number equal token. Sorry for the noise. I hope it's not coming through too badly. All right. So we're going to save the line number. So we see the token. Now we're going to call the lexer.next. Okay, we're going to consume the line number, and then we have to find the statement. And actually, the new line is already taken care of by our lexers, so we don't have to worry about that. Okay, so next exclamation, and that's one of the things I want to worry about. Okay, and we need, well, right, we need to call statement. Well, we'll get the value. Okay. Notice each method is returning its thing. Okay. So we call statement, and then we're going to return a parse dot line with the line number and the statement parse. Okay. And then otherwise, if we don't start with that, I don't know, we probably return an error. Okay, we don't have statement yet either. Let's work on that one first. Func statement produces a parse. Okay. And all right. So here you can see we've consumed the token, and now we've left it so statement's looking at the right character for the first. All right, let's go ahead and add an error case here. My goodness. Case error. We'll take a string just to give a message. And this is return parse error, no line number. Okay. I don't know. We'll see. All right. And then now we're down to the statement. Okay. Statement. The only statement we support at this time is REM. Okay. So if, well, let's deal with it that way. If case, well, no, I guess we know it's equal if it is there. So if dot rem arc equals token, okay, we're gonna consume the token. Okay, token equals lexer.next. And then we're going to return a parse.skip. Okay. And if it's not one of those things, we're going to return parse.error unknown statement. Okay. So that's dead. All right. I think we're ready. If I've done things right, this should pass. Yay. All right. I mean, that's a little bigger step than I like, right? I mean, we ended up writing 3 routines. Let's do some cleanup. Okay, so we'll commit this because we made some progress. Start by parsing a remark statement. And I'm really feeling it at this point. Okay, so one thing is parse. We look at our grammar, and our grammar talks about program, and then parse doesn't mention it. So I want to extract this into program. Program. Okay. I'm going to pull parse up. Now, I'm going to drop this file private. Okay. It would be nice in a way if I could test individual little parser things. Because, yeah, so let's look at our test here. So, see, our test, we have to say, oh, it's parse.program with parse.line in it. And that's fine when we're testing the program, but really, if we want to make sure the lines are doing the right thing, we'd rather just look at the line results. So I don't know. I kind of leave it that you know to call parse for the main parsing, and the others are available more for testing. And I don't know if I should. There are ways to do this, but the easiest way is what I'm doing now. Okay, frankly, I don't know. Maybe I'm not sure what Swift. I don't think it has. I don't know. Does it have a testing identifier? I don't think so. Well, let's look. That's my. I've got to build up my chops here. What do we call this? Access modifier Swift. Four levels. Internal. Can only be accessed from their modules. File private. Well, I mean, that's a pretty complete answer. Yeah, I really wish I had a testing one internal in the target where they're defined. I don't think I'm in that target. I can emphasize it a little bit. I can explicitly make this one public. Let me do that. Oh, really? Okay. I got to bubble it out. Yeah. We'll see. All right. So that was one thing. I would like to make the grammar explicit here. Now, this kind of code, it's repetitious in a way, but it's custom to each situation. So that's a little tricky. Now, the other one we've done, okay. The other thing is these exclamation points. Again, there's different ways to do this. One is you just put in a method next token, and maybe we'll do that. Okay, so func next token. And we'll make it responsible for doing this. So not everybody's out there grabbing the lexer and talking about it. Okay. Oops, where did I pull that from? I guess it was here. Okay. Next token is lexer next. Okay, let's find them here. I don't know if I can call this here. Okay. Okay. So on our main path, we want to make sure that tokens are always being consumed. Okay. So if you match a terminal like line or remark, you need to consume it. If you're matching a non-terminal, the thing you call is the non, that's responsible for doing it. So how can I say it better? So here where I call a line, I may have to know what token to expect so I know how to call things correctly, but I'm not consuming the token myself. I'm saying line is going to call line number, and line number says I need an actual token, and it consumes it. Okay, so exact tokens, terminals here, tokens, that's what gets consumed, and they're responsible for the next token. And if you kind of consistently follow that, you prime the pump, you make sure when you go into any method, it can look at the next token and decide what to do. And if it consumes it, if it needs to use it, it consumes it, and all is good. Okay. What we're going to have is a method for each grammar rule, basically, or a clump of rules. And they're going to be code like this. Now, this is automatable, and you could certainly use a parser with it. I mean, there is nothing that would stop that. Okay, yeah, and you can see I had a problem here. Okay, so there's nothing wrong with using some sort of parser tool that does all this, because this is very repetitive code. If you have a parser tool, you basically feed in the grammar, and the parser tool just deals with it. Okay, nice. All right. The code's not hard to understand once you're used to it. Like once you get the fact of the grammar and that we're reflecting the grammar, this code becomes pretty readable. And stuff like next token helps. We're not having to do this. We can do match things. Okay. We can do require, and maybe that's, I don't know how that would work with this though. But require would be something that says like, if the token is not such and such, then fail, get an error of some sort. Okay, like here, we only support remark. If you don't have it, it's an error. Okay. Let's run the tests. Okay, I think all we did was extract a program method. Make sure I'm right on that. Oh, and next token. Okay, so extract program and next token methods. Okay. And then what happens on this is the error handling kind of complicates things. So let's check those, because I know we haven't been adequate there. And so maybe the question for you is like, what happens if there's an error? All right, so let's add a test. Test a no line number. Remark, and this, again, I'm having these very repetitive tests. Maybe I don't know. I keep diverting, and it's hard to say I'm making progress. But okay, if we give you REM remark, we expect some sort of error, right? I mean, we've got no line number. Okay, so well, this is interesting. I guess what we expect is the program always produces a parse.program. So we expect parse.error, no line number. Okay. And I think this will pass. Maybe not. Maybe we're going to get the infinite loop. Okay, I was thinking next test would show us the infinite loop. This one does. Hopefully you see why, because we went in here, we said if we have a line number, produce the stuff. If we don't have a line number, we're on that REM token, remark token, and we return parse.error. Okay, and we come back here and we're not at end, we're still at remark. Okay, so it goes back in and I'm building up gazillions of lines and stuff as I blow up here. Okay, what we're going to do is a next token, and this is it's an error handling. It's chewing up the error token. Okay, so now let's run this again. Yeah. Okay. So that is an easy mistake to make, and I don't know how much to go into it at this point. All right. Here's the next one, a statement. Okay, so let's add a case for this. No line number. Well, this one is unknown statement. And it's okay. And we should get unknown statement. Okay. And we need our line number. And the error comes in the statement. See, this way of bubbling these errors is probably not so good. All right, but the fact is our program will produce parse.line with token.line 42 and an error statement. Okay. Okay. And again, what have I got wrong here? Line 42. No, something's wrong. Error statement, parent. Okay. All right. We'll dust the glass then. Oh, we still didn't put our next token in. Okay. Let's do that. What's going on? Maybe our lexer doesn't. Let's see what our lexer does. I don't remember what we did. We returned token.error. So it should be token.error there, I thought. All right, let's stop. We'll break here. Let's look at token. Error unrecognized name. Yes. Oh, are we going to get a bunch of them? Let's step over. Okay, and we'll step out. statement parse equals statement. Okay, step over. And let's print statement parse. Statement parse. Error, unknown statement. Step out. Token is not equal at, and what is token now? Not yet implemented. Okay. Step out. I don't know. Well, it's sucking up CPU doing something. Okay. Oh dear. I don't want to make error handling my focus at the moment. It's probably those lowercase letters. Let's test that theory. Yeah, we do not support them yet. Okay. Unknown statement, parsed error statement. Oh. I don't think that was the only thing wrong in there. Didn't look quickly. Okay. Yeah, we just don't support lowercase at this point. All right. So what this shows though is the error handling here is not great. Like what we're doing is we're throwing pieces of error results into larger structures. So it leaves us in an unknown state. Well, no, it's not unknown state. It instead of at the top level knowing there's a failure where you'd have to go digging through the program and find out like, oh, look, there's an unknown statement. That's just not great. Okay. What I think we need to do is more of a try catch thing. So let's add that to the to-do list and let's say error handling with try catch. Okay. So that we can jump out of this low level buried in the middle thing back up to the top level and find a better way to handle it. Okay. Now it complicates it. This is why you end up wanting to use a parser generator tool. All right. But I think where we are, these tests should all pass at this point. Okay. Why are you not? 13 tests. Okay, good. Running nice and quick too. All right. So let's commit this. We added minimal error handling. Okay. And in particular, the thing we did was made sure that any path down through this thing will eventually consume a token. Okay. Even if there's an error, and that means whatever token was offensive, at least it's gone, and we can hope to find the next error and move forward rather than spinning our wheels on the same one. Okay. Let's see. Oh. I think I think that gets us where we wanted to go, though. On the other hand, here's Parser Tests. Okay, so this first one, so now what we have is I have a program I can interpret. And it's structured as this tree. Okay, a program contains lines, which contain tokens and more more parses. Okay, but that is a doable thing. Okay, so I want to do some refactoring over here. Interpreter. Okay. Well, we did initial tests on this. Lexer. So Lexer produces tokens. Parser produces parses. Let's put some groups in here. Cancel that. New group. Let's call this Lexer. I'm going to put Lexer and token. I think I'll put token first because that's the type that's produced. Add another group. Parser. I'm going to slide that down. It produces a parse, and the class is parser. Okay. I don't know if I need to move these tests down just yet, but I will move interpreter test down. Okay. Can fold those. Let's get this one kind of up here. Okay, and that's more like UI. All right, so if I take this program and let's make, well, we got interpreter tests already. Not doing anything either. Okay. So somewhere, let parse equal this. Okay. So parse program. Okay. Now, so test. Let's just say skip. Okay. So what happens is, I think what we're saying is, interpreter, if you gave it, let's build an interpreter. Let interpreter equal interpreter. You give it a parse, and then interpreter.run. Okay, and then assert. Whoops, output is empty. Now we don't have the stuff we need yet. Ugh. Stretch, sorry. Okay. Because I made some interpreter with some silliness here. This is, yeah, we say run it, but really, it's not. Let's do it this way. Let's make a run produces a string. Return not yet. Okay, and then we need an interpreter here, and it takes a parse of type parse and does nothing for the moment. Okay. This test should wake up in a moment. Okay. This test should fail. It should say not yet, and we expected empty string. Init. Okay. Let's just do parsed. Well, no, maybe we can do the real thing. This is our overall test, so it's going to be, it's kind of a duplicate, isn't it? Let's just do parse.skip. Be done with it. Okay, let's try again. Tests. All tests. Okay, where's our failure? Interpreter tests. All right, test skip. Okay, and hopefully not yet. Yeah, okay. So we've extracted out, this is the parse tree of the program we want to test. Pass it into the interpreter, run it, and get some output. Okay, so let's go see interpreter.run. Okay. Now, what we care about is our parse. So where's parse? Oh, I should check that in. Okay. Here's parse. All right. So the deal is, and this is the cleverness in a way. I mean, it's kind of a cool thing. If you knew you had a parse, what would you do to handle it? Okay, and so we're going to define a structure, and actually it's called the visitor pattern, but we're going to say, how do you handle each one of these situations? Okay. If you get an error, we're probably going to print an error message. If you get a program, well, we're probably going to run the stuff inside. If you get a line, how do you run it? If you get a skip, how do you run it? Okay, and that's pretty cool. All right, so I don't know, how can we get this thing kicked off though? Well, I think we need an output stream, which can be a string, I guess. Okay. Right. So we've got this parse. We're gonna have to know the parse. Let's see. So let's save that first. It's not a var. It really is a let. Parse of type parse and self.parse. This keyboard's getting me. It's bigger than my old one. Equal parse. Okay, so now we've got the thing there to run with. This is just sort of an artifact. It's probably not legit. I think we're not going to let you just hand in a string to this, maybe. I don't know. Maybe we should. Okay. But regardless, this one's the one that needs to matter. And I don't know, is there a mutable string in Swift? Or it's all done under the covers and we don't worry about it? Oops. Swift. Yeah, they do copy on write. Yeah. Okay, I guess we'll just, all right, let's say var output equals empty string. Okay. Now, this is such a leap. Ugh. Okay, and I feel like I should get my design patterns book out, but I don't know if I can find it. It's nice to get the pattern, but basically you want to pass in like a state and 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 visit this parse. Okay, so let's do it the non-visitor way first, maybe. All right, and let's say interpret one, a parse, and output empty string. Okay, let's do this. Yeah. Okay, so I'm going to interpret something, and what I get back is what I return. Okay, so I'm accumulating the results. And interpret one, we'll work on names, of course, takes a parse of type parse, and it takes a output of type string, and it produces another string. Okay. Okay, just to kind of make things move forward a little, interpreter test, run this. We should just get a question mark instead of the other thing. Is there an error? Okay, we got a question mark. Good. Interpreter, I'm going to put this over here. Over here. Okay. No, I'm not. Okay. So what I'm going to do is I'm going to look at the parse and do the stuff. So switch parse. Okay. And the parse has, I keep losing it, don't I? Okay, the parse has case error, case this, case that. So let's pull these cases. All right, so case error. This is let message. Okay, we'll return output plus new line plus message. Now let's just assume everything's got new lines where it should. So let's just return output plus message plus new line. Okay. Is that better? Okay. Skip is easy. Don't know what I did. Skip. We're just going to return output. We're not doing anything. A skip does nothing. Okay, so that's a good thing. Let lines return this and line return this for a moment just to get the structure okay. All right, so an error, we just put the message in the errors. Okay, I don't think it's going to matter, but whatever. All right, a program with lines. That's kind of an interesting one. Let's do one line. Okay. Now this is all recursive. Yeah. So, all right. So this one, the line, the token, we don't care about. The parse we do. Statement. Can I say let? .line.program. Okay. Oh, maybe I can do this anyway. Yeah. Okay. So if you have a line and it has a token, we don't do anything with the line number. We just want to do something with the statement. Well, what do we want to do with the statement? We want to interpret it. Now the parse is statement, and we've still passed the output along. Okay, yeah, because we make an exhaustive case, so that doesn't matter. All right, so to handle one line, you ignore the line number and you execute the statement. Okay, to handle a program with a bunch of lines, well, in our simplistic world right now, we just run them all. Okay, so we don't have go-tos, we don't have conditionals, so we can get by with this. In the longer run, it's not going to be adequate. Okay, so this, well, right now, let's just, we're going to interpret, it's a bunch of lines. We're going to interpret, let's just interpret the first line for now. Okay. And again, I'm just trying to kind of get moving a little bit. There might not even be a line and all that. We got to worry about that kind of stuff. Okay. So it's kind of weird. All this mechanism that says, if your program is one line consisting of a skipped statement, which is a remark, you come into program and you're going to interpret line sub 0, which is this parse.line. You come in there, you're going to interpret the statement. The statement does nothing to the output and goes on and returns that output, which comes back from here, which comes back from here, which comes back from here. Okay. And that's kind of it. Now, what you can notice is there's nothing that actually appends to the output except for an error message, which we don't want to actually run with. So it's kind of this is why we want to do print next, because we want to see something that has actual output. Okay, but this is a great step. I mean, that's the nice thing about it. Okay, so we've added interpreter that can handle a program consisting of one REM statement. Okay, and it's kind of a woohoo moment. It's not. Well, it means we have the core of the whole thing in place. Now, I think what I need to do is move into some refactoring kind of thing. This run, I think maybe Basie is the thing that should do that. It should own the program and then assemble the lexing and syntax stuff and then feed the result to the parser. Okay. That seems better to me. Then my interpreter and all that stuff is kind of segregated out. Okay, so let's make a group for that. get it outside? Yes. Okay. All right. And let's run. Should be a no op. Okay. Reorganize files. Okay. So I think what I want to do is make a BASI class that does this piece of things. And this existing BASI tests is really should be testing the BASI class. Okay, so we're due for a break. So let's take a break, another 3-minute break, and we'll come back and split that apart a little more. All right, see you in a couple minutes. Hey, welcome back. All right, so let's get this thing in shape. Let's fix that name. BASI tests. BASI tests. Okay. Comment. Interpreter of parse.skip. Oh, we just changed that to be, yeah. Okay. Let's save that. Let's modify. Oh, no, BASI app. We just want BASI. New file. Switch file. BASI. Hard to get these in the right place. Yeah, there we go. Okay. So instead of interpreter here, well, it can still be called interpreter, but let's do BASI with program. RAM. Okay. And the output is interpreter.run with no program because we already gave it to it. And assert that. Okay. Now BASI is over here. This is class BASI. And its init takes a program of type string. And it has run, right? Yeah. A function run produces output. Okay, and we'll make this return nothing, return question marks, because we're looking for nothing. And let's run it. Should be question marks. Yep. Okay. Now, this thing basically we're wiring everything up. Okay, so we need an interpreter. Let interpreter be of type interpreter. And we're going to say interpreter equals interpreter. All right. It needs a parse. Where's parser? Well, let's maybe go the other way. Parse. Interpreter. All right, let's let parse equal parser with lexer with program. And the interpreter is parser.parse. Okay. One, two. Okay. So that's ready to go. Parser equal that. And then we're going to return interpreter.run. Okay. Let's see this pass. All right, and now our interpreter, wherever that got off to. Did I just close it? Okay, interpreter doesn't need this anymore. All right, and I'm going to change this name to interpret. Okay, and run our tests. I think there's one leftover problem. No? Okay. Right. So we made basic wire up lexer, parser, and interpreter to run a program. And that's sort of your high-level entry point with strings going in and strings going out, or a program string. Okay, wow. I'm terrible at keeping up with my to-do, aren't I? Run a REM-only program. We did that. That is good. Okay, so we are end-to-end on our whole thing. Let's update this. Okay, so parse and interpret. All right, and let's make these green. Character styles, field types. I think it's this green, yeah. Okay, so a little progress. I guess I can take the whole line, right? Good, and this check mark here. Bullet. Say check mark. Okay. We're ready to start print. I feel like there's missing concepts or something still, but error handling. Maybe that's the one we should get right. Let's either this, let's move this one up. I don't know if it goes before or after print, but we got to do something at some point. Print, the simplest print just prints a new line, and we could easily do that. Maybe that would be a good thing. I don't know if we can quite do it in 20 minutes, but and these parameterized tests, we keep running tests that would be better parameterized. Let's see. Okay, so print. Let's go back in here, this 8K basic, 8K bytes, right? Print. Well, this stuff up here is all the run package, and maybe that's what BASI should be is load and save and run. Okay. It's yeah okay. Talk about your old problems, right? Um, Insert 3 nulls at the start of each line to eliminate change return bounce problems. So on the old teletypes, um, it would basically print your line, but you could also tell it to punch it onto paper tape, and paper tape is a row of probably 7 or 8 holes potentially, and one row per character, and if you're should be 0 when entering paper tapes, and if you're punching tapes, you need more than 3, and maybe higher settings. This is just not a problem now. So nice not to have to worry about that stuff. I mean, if you wanted to edit that stuff, you would, print empty sections and splice it in with Scotch tape. Okay, but this is all okay. List, run, new, continue, and load, and actually save. Okay. But let's find print. Print X, so you can print a value. You can print a string, a numeric value, or a string. The comma and semicolon, comma would basically, I think it was like 10 character columns or something. It would skip to the next column, so you kind of get a table looking thing. And semicolon just squeezes it in as well as it can. So no spacing between stuff. Okay, so our statement is print optional expressions followed by commas or semicolon and more expressions. Okay, so like how complicated do we want to get to start with? All right, if I could print nothing and just get a new empty line, that's probably okay for now. All right, I'm talking instead of doing. All right, so this is one we can, let's make an overall test. So BASI here is pretty good place for overall tests. All right, so let's function test 20 print, and program will just be 20 print, and this is all the same, and the output is going to be new line. Okay, so a print with nothing else will say produces an empty line. Okay, this test should fail. Yep, something about unknown statement. Good. Okay, we had our error message in the middle there. All right, now I'm going to set this aside like that. Okay, and now it should only run one test. Yep. Okay, this is my end result. Let's focus on the pieces. Okay, so Lexer, I keep closing these things. Okay, I don't need to do over here. Lexer and token. Okay. Yeah, I don't know if the sequence thing is quite right yet. Okay, but let's get print. So this is just the keyword print. Okay. And the lexer, which I seem to have lost. Okay, where's lexer? It doesn't know how to match the word print yet. Okay. Let's get a test for it. Okay. And we're just going to do something like, where's REM? Yeah, like this. Okay. So we're just trying to get that print token. And we're not worrying about, there might be commas and expressions and all that stuff. We're just after the keyword. Okay. And let's say print. And we want token.print. So we're just trying to recognize this thing. And we want to consume print. Okay. All right. This should fail. Okay. We got unrecognized name. I guess that's down here. Unrecognized name is not equal to print. Okay. We have those optionals. Is that working for us? I don't know. Okay, so the thing the optional is giving at end that we were looking for, it would give us nil instead. I don't know. I think it's nicer to kind of have the null object there. Which means the sequence is not helping us that much and probably should be ripped out at some point. Okay, print and the lexer. So if we match, okay, if the value starts with REM, do that. Well, if it starts with print, we're going to skip let's implement it and then we'll do it. Okay. Index plus equals print dot count. So we're skipping over print and we're returning token dot print. Okay. Parser Tests. Run this. Should be good. Okay. So we added print as a token. BASI test did not match any files known. Okay, let's cancel this. I think it's because I changed the case. Okay. There's always a way. Okay, that one's still no good. All right, all the tests should be passing. Yep, okay. So that's the Lexer test. The Lexer. Well, let me do the cleanup I should be doing. I want to say skip word or something like that. Yeah, I think skip word would be fine. Okay, just to try and keep things sensible. This one's a little funny. I mean, in effect, I do skip the word REM, but I'm really skipping everything till a new line, so it's kind of pointless. Okay. Test should still pass. All right, now the parser. Well, we don't have a print node. Okay, so in effect, what I'm saying is we need a print, but for now, we're not going to do anything complex, right? We really should print a sequence of things. An array of expressions or an array of parses, really. But we're going to be primitive here for now. So the parser, we got a parser test. Okay, so yeah, so I think we're gonna test print. Statement. Okay, and so the program is 25 print, and the parser is this. The result is that. And the result, let's see, it's going to be more like REM. Parse program, parse line, token 25, parse.print. Okay, and that should fail because nothing produces parse.print. Okay, I guess it fails here in interpret because we haven't done anything. Case print return print not implemented. Okay, it just kind of blows up the output. That's what we're going to allow for now. Where's my parser tests? Yeah. All right, and it should be that unknown statement is not equal to print. Okay, here's unknown statement. All right, so statement, let's go to our grammar. Statement goes to print. Okay, so if their mark is token, otherwise, if their mark is, if print is token, Then we're going to consume it, and we'll return parse.print. Okay, so a print statement consists of the line number, but we're just worried about the actual body of the statement. Okay, and if you say print, then we get a print parse, and that is cool. All right, and then parse, let's hide that, interpreter. Okay, this is clearly not right. Let's find the interpreter tests. Let's add a print. Well, fine. Test print. Parse program, line 10, parse.print. And that, and the output should be a new line. Skip should pass, print should fail, should be empty. Oh, it should be our junk. Okay, and what print should do is return output plus new line. Okay, now we should be able to go back to basic tests, and this should pass. All right, all tests should be passing at this point. Yeah. All right, I was wrong. We could do it in 20 minutes. We could do it in 12 minutes for the basic print like that. All right, let's lock in what we got here. Make print with no arguments work for parsing and interpreter. Okay, and I don't know, to me that's more satisfying because we've done the horizontal slice. You know, if we'd spent the same amount of time, we'd have 3 more tokens, you know, if we'd worked from the front end to the back end. So, yeah, this is good. Next, all right, let's see. This is print, no arguments. And we also need print with numbers, print with strings, print with comma, and print with semicolon. That's a little tricky, the comma and semicolon stuff. All right. This one works. Let's click credit, as it were. All right. Yeah, I'm very happy that adding the print like that was so quick. You know, that's what we want. It took us most of 2 sessions to get that far, but they're pretty good. Now, we don't have, it's a question to me like how much other stuff should be there. I think I need at least, well, it's different things we could do. If we did print with numbers, we could go and do the whole expressions and all that stuff. That would be interesting at some level. If we did go to, we could at least have a loop that just printed hello, 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 hello. A little weird because we collect all the output and look at it at the end, so it doesn't work very well with infinite loops. Let's see, print if statement would let us do conditional loops. I don't know. We got to figure out what's a path. Maybe print with numbers and then generalize to expressions would be a good way to go. And that will get us a lot of what mechanism we need for assignments, which we don't support yet. And I should put that one in there. Oops. Simple assignment. That. All right. So I do want to address this. I do feel like we're to the point we need this because these tests are looking. Compiler tests are notorious for this. Everything is take a program. In this case, take the program, interpret. Build the interpreter from it, run the interpreter, check the output. Same thing here. It may be time for that. It's even worse on these token tests because they're so small and I say boring. I don't like seeing boilerplate. So that tells me maybe I should pull this in. I don't want to blend too many projects at once because I'm already thinking interpreter and compiler and refactoring, and this is another diversion in a way. But on the other hand, I wouldn't mind growing this package out a bit, and compiler's got some nice things that might be able to do that. I don't think we need this digits character thing. We'll figure that out in the future if we need to. All right. Anyway, I think we'll stop here. And I'm happy with our session. We dealt with sequence. Maybe we got the wrong answer. Who knows? Should we work with characters? No, but we cleaned up indexing and we got the REM only program running and we got our print working. Very minimal print. It'll have to grow, but that's okay. We'll get there. So thanks for joining me today. Hope I can catch you in the future, and have a good evening. Tomorrow's the same time, 9 to 11:30 Central Time, 10 to 12:30 Eastern Time. And I think that's 3 to 5:30 UTC. I hope I'm getting that right. All right, take care. Bye-bye.